polygons are. So we're working with the area. We're also going to work with some similar polygons as well. So area, there it is. Right? So rectangle, area base times height. Or you may have heard of it length times width. I'm calling it base times height. That shouldn't be new. Parallelogram, maybe you know this, maybe you don't. It's also base times height. But remember what height is. Height and altitude are the same thing. It's when you draw a 90-degree or perpendicular to a side. So it's like you stand here and drop a penny, it goes straight up and down. You can almost see why this would be base times height. You can take this little triangle, you kind of cut it out with scissors. You can actually put it in here. And then I can kind of see that rectangle shape again. So that's why this one is base times height. A triangle area is 1/2 base times height. So here's base, here's height. It's all relatively speaking now. You can make any of these sides can be a base. So if I want this one to be a base, you go to the opposite vertex and you drop that perpendicular, and this would be the height relative to that base. If you're at this base, you would drop a perpendicular, and that would be the height relative to that base. So it all depends on what you're using as your base. So in this particular example, here's my base, here's my height. It's half. If you were to kind of duplicate, clone this triangle, kind of flip it and put it over here, you get this nice parallelogram as, again, base times height, but I'm only looking at half of it. So that's why it's 1/2 base times height. That was not a very good picture. But these are ones you should know. Now, they're on your diagram, right? They're on your formula sheet. But you should kind of know these. It's better to know this than to have to keep referring to that. What else we got? Trapezoid. I can't remember. They might have it in a slightly different. I'm looking over your shoulder here. Trapezoid. I don't think it's the exact one. I don't think about it as half H, H1 plus H2. I look at the bases, and the bases again are the parallel sides, and I say add them and take the divide by 2 to get the average. You're basically averaging these bases, and then you're multiplying by the height. So for me, that's an easier way to remember the formula. Yeah. Yes, you can use the formula sheet. You can use the formula sheet. But again, it's always better to know it. Somehow, to me, it stops the flow. You have to stop, look up a formula, and come back. So it's easy to remember this one. Average those base lengths and multiply times the height. Now, rhombus and height, these are not on your formula sheet. So even though you have your formula sheet with you, you will not have these. So you do have to know them. Luckily, they're the same. Your area is 1/2. B1 and B2 stand for the diagonals. So if this is a rhombus, and it is, that's the other side of congruent, this diagonal times this diagonal times 1/2. You get the area. Height is the same thing. This diagonal times this diagonal times 1/2. And real quickly, just because I think it's kind of cool why that works, here's a rhombus, which means all my sides are congruent. Here's a kite where I've got 2 sets of congruent sides. The proof or the thinking about this is kind of the same. I don't know, if you look at these 2 triangles, I'm going to look at like this one and this one. Everybody's looking because I see people doing this, so make sure we're looking at that. I say there's a congruent triangle. Why do I say that? The blue one and the red one. Why are those congruent? Why? We've got a side. Because it's a rhombus, you've got those 2 sides, and reflexive, you've got that side. Congruent triangles. This, I'm calling the length of PRX. I'm just calling it X. I don't know what it is. Let's call it X. And I'm calling this distance here S and Q Y. So when I cut them in half, I'm saying this one's Y over 2 and that one's Y over 2. Because what do I know about rhombuses, which are parallelograms? The diagonals do what? Bisect each other. So our quadrilateral knowledge comes back. So Y over 2. If I want the area of just this triangle right here, it's 1/2 base times height. Right? That's the base, that's the height, I'm taking 1/2. But I have 2 of these triangles and they're congruent. So I have 2 of these. So it kind of knocks out that. And now I've got X, Y over 2. Another way to write that is 1/2 X times Y. So there's the X, there's the Y. That's where it comes from. You can do the same kind of analysis with the heights. These are also congruent triangles here. I've got a side angle, side congruence, or side, however you want to look at it. Same thing. And I like kind of seeing where it comes from in case I forget it. I know I can get it again. So 1/2 diagonal 1 times diagonal 2, and these were just words kind of explaining what I just said. Some examples. Find the area of parallelogram. So this is example A on the paper here. Now the shading did not copy well, so if you want to, darken on your paper, you can. You can see what they look like up here. I want the gray, right? So base times height. Now when you're doing these problems, this is my expectation. I want to see the formula, and then you're going to kind of substitute in the values. Everything's all depending on how you look at it. If I'm looking at it, straight on, and if I say this is the base, then this base, because it's a parallelogram, this is 12, so that's 12. Opposite sides are common. And remember what height is. Height is starting at vertex, and by dropping the penny down, you're getting a nice perpendicular. They're telling me it's 15. So the area of this parallelogram is 15 times 12, and those of you with a calculator, figure that out for me. 15 times 12? Yes, sir? 180. And remember, these are square units because I'm finding area. I don't know what units you're using if I'm just using that word. Another way to look at it goes, I could have tilted my head. What if I made this the base over here? 18, right? And then where's my altitude? I can see it, my height. Because this is dropping at 90 degrees, that perpendicular to that side. It's 10. So I could have just done 18 times 10. You're still going to get 180. It's still going to be the same area, but it's all relative to whatever you're thinking about as the base. Does that make sense? Does that make sense? Yes. Good. Okay. Area of a triangle. And again, my expectations, I want to see you write out the formula first. And it is my expectation because I want you to be nice and organized so you can see what you're doing. Not only so that I can see what you're doing. 1/2 base times height. And again, any of these can be the bases. You choose. But then you have to figure out what's my height. It may not be wise to choose this as your base, because then your height is somewhere over here. I don't know. So I'm going to pick the one where I do know what the height is. This one. So I'm going to make this guy my base, and this guy my height. In this case, I don't need the 13 and 20. They're there. So it's your job to know what's the important information. So it's going to be 1/2 21 times 12. So if we got it calculated here, 26 for a minute. Right? We're just working with area. Okay, this is a right triangle here in example C. They're telling me the area. The area is 50 square inches. They're telling me that. Right? Area of the triangle is this. Its base is 4 times its height. Find the base and the height. So they gave you a picture. Now usually, or often, they don't give you the picture. So you basically have to be able to figure out. So you say, well, if I let h be the height, then the base equals 4 times the height. So you can kind of use those words to figure out what you decide to do. Draw your own picture and get them to you. So let's see, again, you write out the formula first. Area is 1/2 base times height in the triangle. I know the area. It's 50 square inches, so I put that here. 1/2. I'm calling my base 4h, and I'm calling my height h. So we put all those substitution pieces in. Don't do it in your head. Don't condense it. Very nice to see this step. In case you make a mistake, you can really see what you're doing. You have choices. You can take 1/4, or you can combine these first. I think I'm going to combine those pieces first to get multiplication. It's okay if you do this a different way. And now 1/4 is 2. So divide by 2. So what's h? H squared is 25 is h. 5, 4. Okay, now you do your analysis. 5, yep, you get principal x and bases. If I put in -5s, I get negative side length. So I'm going to reject that. But it looks like it's 5. Now I have to go back and say, did I answer the question? No. It said find the base and the height. I only found one thing. So I found the height to be 5. But then what's my base? 4 times 5. 20 and inches. And we do units. Now let's check what are the units. Yeah? Not for that, right? No. Yes. Of course it is. Okay. Other examples here. This is a rhombus. The area of a rhombus, this is the new one that's not on your formula sheet. So you're going to have to know this one. 1/2 b1 times b2, the diameter. And again, attention. The thing is, on the SOL, they will not let me answer any question. So I want you to kind of be brave and go see if you can figure it out based on what it looks like. And that was this 12. So my diagonal one is 24, which is one bridge, and that was 14. So the area is going to be half of 14 times 12. And if you multiply that out, what do you get? Oh, 24, I'm sorry. Right, that's 24. It is 168 square centimeters. Because again, areas are square units. Go to the area of the kite. So this kite, you're telling me this piece is 2, right? There's no, that means just this little piece, not the whole thing. But this piece is 8. Now I have to know something about kites. If this is 6, what's this piece? 6. How that works, like these two are the congruent angles, like these two, right? There's my congruent triangles. So these two pieces are congruent. So I want to find the area of the kite. Area is still 1/2 diagonal 1 times diagonal 2. So 1/2, the diagonal one, I'll call it this one, 12. And then what's the other diagonal? So, I can kind of do this one in my head, right? I know half percent is 5, and 5 times 12 is, 60 square feet. Don't check what you're doing. Pretty easy. Okay, we're on example F already. Finding the measure of the base of this trapezoid if I know the area is 95 square meters. So what's our area? And I always write the area down the way I think about it. 1/2 is 1 plus base 2 times the height. This is different than what's on the formula sheet, or at least it's written a little differently. They're equivalent. It's just how I think about it. Add the base and take F multiplied by height. So I know the area is 95, and it's going to be 1/2. Well, one base is x, and the other base is x plus 3, and the height is 10. So I got to solve this thing. Well, let's see, half a ten I can do that. That's 5. And what's inside here? X plus x, 2x. Alright. So your choices are you can distribute. I'm going to try and divide. I like to divide it when I see these are divisible. I do it just to make smaller numbers because for me I make less mistakes. So 95 divided by 5, I want to say 19. But I could be wrong, so check my words here. Is that right? Am I doing it? There? Yay! Okay. Then I subtract the 3, and then I divide by 2. So x is 8. Now what do they want me to find? Find the bases, right? Don't just say, yeah, I found x and move on. I want the bases. So one base here is x, that's 8 meters. And the other base is x plus 3, 8 plus 3, 11 meters. So those are the bases. Simple, right? That was easy. Sure is. Which is why we're going to do a little bonus, because you're 8th grade people taking geometry. You guys are the cream of the crop. So a little bit extra. Now if you look at the box on your paper, see that little box that says area formula at the very top? Underneath it, it says area of a regular polygon. You see that? Who sees it? Okay. And it says A equals 1/2 AP. I don't know what that beta is for. We'll probably get rid of that. We're working with how you find the area of a regular polygon. You might need another piece of paper depending on how big or small you write to kind of write the note on this. Because it's not on your official note. You're actually going to have to maybe write this down. So if you want to take out a piece of paper, go ahead and do that right now. So we're learning a new word. Look at this word here. It sounds to me like you're talking, you have a list and you're talking about that animal that likes to hide. I'm going to pop them. Yeah, right, but a possum. Oh, whenever I say it, I feel like I'm like whiskey a little bit. What is an possum? So if you have a regular polygon, and you kind of divide up so that the center of that polygon touches all the vertices. The apophthegm is if you take one of those triangles and you find the height or an altitude, that thing's called an apophthegm. It's the height of one of the triangles that you can form in a regular polygon. That's what it is. Remember what regular means. All these are congruent, right? As well as those angles are all congruent. If think about it inscribed in a circle, we would see that all these slopes are really kind of radii, so all those are congruent. And so what can I say about all these different triangles that form in a regular polygon? congruent, side, 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 congruent. So when you do this, you have a regular polygon and you divide it up into all those different triangles, you'll get n congruent triangles, in this case 6 congruent triangles. For this one, my n is 6, just so this is my number here. Okay, great. And so if I want to find the area of this polygon, I would basically find the area of one of the triangles and just multiply by n, or in this case 6, right? Does that make sense? How you find the area? So let's see if we can find the area of one of those triangles. So it's base, 1/2 base times height. Now, I'm calling my base the side because it's a polygon. So it's 1/2 side times the height, which I'm calling A. And I'm just going to turn it around for a second, just because it's a little more useful to be an A times S. Right, that's one of these triangles. All right. And how many of those triangles do I have? How many triangles do I have? Is an n-sided regular polygon? Am I right? Right here? Here? 6 of them, right? So if this was 10, how many triangles would I have? 10. So if this was an n-sided one, how many would I have? 10. So this gives me the area of the whole thing, right? 1/2 times the apothem times the side times the number of triangles I have, which is the same as the number of sides. Well, look at this. What's S times N? Well, that's one side times the number of sides gives you what? It gives me what measurement? If I know this, say this is 10, and I say 10 times 6, what did I just find? Yes, perimeter. So S times N is another name for perimeter. So the area of a regular polygon is 1/2 times the apothem, one of these guys, times the perimeter, and you get the area of these guys here. So so far so good? Maybe? So we have that formula, and that's what it says in your paper. I don't know why there's a big giant A next to it, so you can cross that out. If you look in your paper, see which says 1/2 AP, there's a capital A next to that, just cross that out. I don't know what that is. I don't feel bad. This is the area of a polygon. So let's say I want to find this one. Okay, so this N is 6, right? I want to kind of blow this triangle up a little bit so I can see it a little bit better. Alright, here's my apothem. This whole thing is a side. Do I know what this angle measure is? Or can I find it? Yeah, how can I find it? Yeah. Right? This whole thing is 360. These are all congruent triangles, so these are all congruent angles. This particular one has 6 sides. So what's this angle? 60 degrees. Well, let's see. How does that help me now? This I know is congruent, right? We talked about how this is congruent. I also know what else. Well, this is congruent to itself. This is the isosceles. Yeah, Madison? The two angles on the outside are each 60. They're each 60, but let's go one better. They're congruent. What I'm looking for now is do I have congruent triangles? But you're absolutely right. You're absolutely right. Because this is isosceles, they are in this case going to be 60. So what do I have here? I've got either angle side. I've also got hypotenuse leg. These are congruent triangles, are they not? So what is each of these angles? 30. Okay. Those are 30. And so if I can find this, and I can find this, I can get the area of that triangle. This is a right triangle, yes? And I know an angle measure, and I know this right here, but this is the side. I'm not doing the wrong problem here. This is this side. We'll probably be here. I would call it 5. Okay. Calling that 5. That means this one's 5. And I want to find this. How do I do that? Yes. How do I do that? From here? Well, I don't know this side. So if I know an angle and I know a side, this case is a 30, 60, 90, which is true. Let's pretend we don't know anything special about 30, 60, 90s, only because they're not always that nice little triangles. What's another way to find the side one? Just like halfway up. Yeah, trigonometry ratios. So let's say I want to find A, remember? So this one is 30 degrees I don't know this one, but it's an adjacent, and this is a hypotenuse. So if I want to find A, right, I would say the cosine of 30 is A over 5, and that means that A is 5 cosine 30 degrees, isn't it? Yes, yes it is. So now can I find this little piece right here? And I'm just going to call that a little b just so I can think about what that is. I'm working on now what a side is. I'm just going to work on this whole side. So now it's sine, right? Sine of 30 will be b over 5, right? Opposite over hypotenuse, which means this little piece here that I'm calling b is 5 sine of 30. Here's my b so far. Now these are congruent, right? Congruent triangles. So I really need two of these. So it's really 10 sine 30 is one of the sides, isn't it? With me? Yeah? Anybody? Anybody? Hey, one person. So I got that, and then but how many sides do I want here? 6 of them. So to find the perimeter, it's the side times n. So it's going to be 10 sine 30 times 6, which is 60 sine 30. Right? Who followed this bit and this bit? 2 people. Okay, got 4 or 5 of them. I'm going to plug it into area equals 1/2 approximate times perimeter. So 1/2, the approximate is 5 cosine 30. 5. And the perimeter is right here at 60 sine 30. I think that's easier for me to gather up all these numbers here. 60 times 5 times a half, almost 150. All right? 150 times the cosine of 30 times the sine of 30 will be the area of this whole thing. You know? So now I need my calculator. What's the first thing we got to do if we're here too? Change your degrees. Whoops, I'm going to do it. Yeah, Tom? Right? If you don't remember how to do that, press your remote button. I already did it on my calculator. If yours was cleared out, and when it was, it probably said radians. So change it to degrees. Oh, goodness. And then I'm going to put in 150. Whoops. Times the cosine. Here it is. Cosine of 30 times the sine of 30. And now I have, it's approximately 64.95 square units. Is the area of that equation? How fun is that? That's fun. So, okay, guys, let me still have one more number. So you can actually, with regular polygons, you can find this stuff. So it's nicer when they tell you what they are, but if they don't, we can just straight find it. So, yeah, there's one of those on the U-tries. I do have another one here. This is a nonagon. Just real quick to kind of review what we did. Its area is 1/2 AP, and it helps to make one of the triangles big, right angle. This is a nonagon. There's 9 of them, 360 all the way around. What's this whole thing? 40. So what's each little piece? 20. If I want to find the hypotenuse, right here, that's a cosine. So it's going to be cosine 20 is A over 5. So that's A equals 5 cosine 20. That's A. When you're working on perimeter, now I have to find one of these little pieces. So I call that B, you know, whatever you want. The sine of 20 is B over 5. So B is 5 sine 20. But I want 2 of them. So this becomes 2 of that. Once I've got 9 of them, I have to multiply by 9. Wait, 90 sine 20 will be the perimeter. So 1/2 5 cosine 20 degrees minus 90 sine 20. I find it easier to combine those numbers. 450 over square together, so 45.5. And if you do this one right, I can't remember what the answer is. Let me again, see if you can get 72.3 on those square units, and that's how you do that. The reason I'm bringing it up is because all these U tries are pretty easy, but I do have one of these on here. So I do want you to try these U tries. And this is page 1 with answers. I'll flip it to page 2. I can flip back. So some of you may be on D and E already, so I'll flip there. And some of you may be on the last one. So I'll show you what you should get, and then we can compare our notes. We're all kind of done. So I'm putting it back here, but it could be turned. Yeah, I just did this one. So there's a question on this. I'm looking. Not everybody is writing out the blank formula first. It actually is kind of important. It shows first of all you know what you're doing, and then it helps you kind of guide how to make these substitutions. And for me, when I make substitution, half of 2 is 1, x times x squared. You just have to take the square root. Remember, there are 2 square roots of this, approximately plus or minus 8.5. We're rejecting the negative because of the negative side, the diagonal length. You should get pretty close to that. So area is 1/2 the approximate times the perimeter. So I've got this pentagon over here, which means I'm going to blow up this little set right here so I can look at it a little bit better. So I've got 8, and I've got 8, and I'm kind of dropping this right here. I know these are 2 congruent triangles. I can find this big angle right here by taking 360 and divide by 5, which is 72, I think, right? 72 for this whole big thing? These are 2 congruent triangles, so I take half of that and I get, what, 36? Is that right? Yeah? Okay, so I need the apothem. This is the apothem right here. So that means that the cosine of 36 degrees is a over 8, which means a is 8 times the cosine of 30. So there's my apothem taken care of. Now I have to find the perimeter. So perimeter, well, if I find this thing, then I can find this whole thing, and then I'm going to multiply it by 5 because there's 5 sides. So I can find this side. I'm just going to put a little x here to find this measurement. The sine of 36 is x over 8. So that means that x is 8 times the sine of 36. Now a whole side, right, if this whole thing is s, that whole thing is 2 of these. And so that's 16 sine 36 degrees. Does that make sense? Okay? That's this whole side. Now how many of those sides do I have? I have 5 of them. So that means if I want the whole perimeter, it's this thing times 5. And 5 times 16 is 80. And this is where I'm likely to get my mistakes and stuff like that. So is that right? That's the perimeter, and that's the apothem. And now I can put it in here. So a equals 1/2 a, which is 8 cosine 30 degrees, 36 rather, sorry. And then the sine is 80. The sine 36 degrees. I mean, are you following or not? I can't tell. You're very quiet. All right, and then I like to just deal with my numbers first. It's just for, you don't have to, but I think half times 8 is 4, and 4 times 80 is 320 times the cosine of 36 times the sine of 36. And now I'm ready for my calculator. Notice how I don't estimate this. I don't estimate this at all. I want to kind of get to my final answer in one step so that I can be as accurate as I can be. So it looks like 320 times the cosine of 36 times the sine of 36 degrees, and 152.169. If you round it to the nearest hundred, 152.17. And these are square units. They didn't give me units, so I'm just going to square it. If anybody will actually get that? Got a couple people? Anybody close? Good, good. You get at least. So anyway, just keep these steps handy if you want to kind of do one of these. Now let's do the stuff on the back. Now the stuff on the back. I think we kind of did it a little bit, I think, in a previous question somewhere. This is using relationship between perimeter and area if you have similar polygons? So what is the relationship? Can you close that, please, because I just closed it. So what is the relationship between area and perimeter? So there's a lot going on here. Basically what this says is, if this is like a length is A units, this length is B units, and these are similar polygons. So that's a little similar thing if I see it. So we know A to B will give me a side length ratio. And because a perimeter is made up of sides, the perimeter uses that same ratio as the side ratio. So we can call it a side slash perimeter ratio. Now what's the relationship between that and the area ratio? Is you square that. That's the relationship between sides and perimeters and areas. And we're going to see how this works or what to do with that. So for example, and this is on the paper there, example A on the back. And you know where I am? I'm not sure where we are. I'm on the back, example A. So I've got a red triangle, I've got a blue triangle. It says find the ratio of the perimeters of the red triangle to the blue triangle. Well, I know the sides go 8 to 12. And I want to reduce that thing. So 8 to 12 comes up with 4, right? 3? So that is the ratio of the perimeters, because it's going to be the same as the ratios of the sides. What if they want the ratio of the areas? Well, you just take the ratio of the perimeters or the ratio of the sides and you square it, and you get 4 over 9. See how I went from here to here? 2 squared, 3 squared. So this gives me side lengths and perimeter. And this gives me area ratio. So we'll see what you do with that in a second, okay? So squaring it. So what do you do with this? So, for example, if I have 2 triangles, this is the best way. The 2 triangles. So I've got triangle ABC, and I need to see pictures. Can't do it without it. And its perimeter is 24 feet. And its area is also 24. This is 24 square feet. Alright? And again, I like drawing these little pictures with the information right next to it. Now, JKL is a similar triangle. When I label it, notice that this one ABC, so did JKL, so they're kind of looking at me in the same way. What do I know about this one? I only know its perimeter. And it's 36 feet. And they want you to find the area. So this is the kind of problem that this will help you solve. Now, what's the ratio of perimeters? Ratio of perimeters, yeah. Ratio, what is it? Ratio, already like reduced it, right? You just take that 24 over 36, and she said, why don't you just reduce that, which is always a good idea. So divide by, divide by 12. So that becomes a 3, and that becomes a, no, that's 2 and a 3, sorry. So what's the ratio of the areas? Well, that's the ratio of perimeters. Ratio of areas. 4 over 9. So our basic rule is, if you know the side or perimeter, and let's say that's A over B, then your area is A squared over B squared. And you can remember that because don't you square sides to get an area? Areas are always square and stuff. So what do you do with that? I want to find the area. I know the area ratio. Going from this triangle to that triangle, it's 4 to 9. So I know this one's area is 24. This is the one I don't know. So you use that ratio to find these missing pieces. So you can do a cross product. 4x will be whatever 24 times 9 is, which is 24, actually no, I don't know, 216. And so you divide both sides by x, you divide by 4 rather, divide by 4, and you get 54. And what am I using? Does that make sense? You find the areas, you're setting up in proportion. We'll do another example. Here. This looks like example 1. The ratio of the area of 2 regular decagons is 20:36. What is the ratio of their side lengths? So these are area ratios, and I do like to label them just so I can see what I'm doing, and I prefer fraction form. Let's put that in simplest form. Equals factor, let's see, 4, let's see, is that it? Yeah. I just reduced the fraction, and so how am I going to find what the side or perimeter ratio is? Christian? Yeah, right, because if you know the size, and we'll just kind of write the little rule again until it's kind of in our brains here. So if you know the side and you're going to area, you square it. But if I know the area and I'm going to sides, I take the square root. So it's the square root of 5 over the square root of 9, and the square root of 9 is 3. So that would be the side ratios are to that square root times 3 ratio. Let's do what that actually is to find the value. So this is example C on your paper on the back. Given the figures are similar, find the area of the smaller figure. So this is what I don't know. These are similar hexagons. I know this area is a little hard to read. I think that's 210 square inches. Yeah. So I label this when I work these problems, and if you're looking for a way to be organized. So the side length ratio, I'm going to put that over here. Ratio. What's the ratio, say, from going this one to this one? What's the ratio of the side? 7 to 9. Yeah, it's that easy. You're looking this one's that's right here. This one's 7, and this one's 9. So the side ratios are 7 to 9. That would be the perimeter ratio too. Now if I want the area ratio, what's that? Oh, alright. Yeah, just square them. Okay, so I know what their area ratio is, and that's going red to blue, 49 to 81. Well, let's see, I don't know the red one, but this one is 210. And they should be in that same ratio. So we set up the proportion. So 81x is going to be, whatever that is. So 81x is 210 times 49. We'll just do it cross by x. 10290. Divide that by 81. And I get approximately 127.04. And let's not forget our units, these are in inches and square inches. So using the ratios, and not doing anything else really, I can find that area. So that's kind of the cool bit. And now I've got another example here. These are similar hexagons. Find AB. Wait, what am I finding? AB. Oh, that's this. X. Right, so I'm just going to put an X here. This is what I want to find. Now I know it's kind of matched over here. It's 4. But I know their areas. So let's see. The area ratio is 128 over 18, right? It's best to simplify it if you can. Now, if you're having trouble, I don't like to simplify fractions. You can use the calculator, 128 divided by 18, and then make a fraction out of that. Press the math button, and then press fraction. 64 over 9. Quick and lazy way, if you want to reduce a fraction. That's the area ratio. But I want sides. So I guess I need the side ratio. What's the side ratio? What? 8 over 3. So you have to remember where you're going. If you're going from sides to area, you square it. But if you're going from areas to side, you take the square root. Doesn't it? Raise your hand. Oh, yeah. And if you're like, no, please ask the question. Because now I know the side ratio going 8 to 3, big to small. So this one I don't know, so that's where the x goes, the big to small, but I do know the other one. So the other trick to this is not only finding the ratio, but make sure you're setting up your proportion correctly. Big to small, and then 3x equals 32, which means x is, that's not exactly, it's just 32 thirds. But let's see what kind of number that is. 32 thirds, 10.67-ish. Squares, just 70, I'm finding a side, right, so just 70, that's not an area. Yes?
I multiplied 4 smaller side number by 8.
Yeah, because want to say, here's the blanket rule, so just make, if you see the proportion, because it was on the bottom, no, divide by that number. So, just make sure that you set up the ratio. Don't look for a shortcut just yet. Okay? And I believe we're up to you guys already. I mean, that's really all there is to this ratio stuff. So give this a go. Setting up, and I think it's really important to, like, I'm a mess, I'm not real neat, but I do like to try and be organized. What do I know? What's this one? Because it's very easy to confuse this stuff, so try and be as organized as you can with your work. I will say this last test in particular, I didn't even yet, it was very hard for me sometimes to figure out what we were doing because it was a little bit disorganized for some people. So even I'm not real that neat, and my handwriting's horrible, but see if there is a way to kind of organize your thoughts so you can find things again after you do some work. So give these a try. I'll put the answers up so you can check them. So, and then I'll scroll back, but I'm just going to kind of run through. Okay, so there's my large baking pan, and then I've got a smaller, similar baking pan. I know the area of this guy, and they want you to find the width. Okay, great. What do I do? Okay, so I know this area. Yeah, Christian. Yeah, I know this area too. It's just length times width. So that one's 150 square inches. So I can find the area ratio. And again, I like seeing this. Here's when we're doing my area work. And it's going to be 150 over 96, which when you reduce that, you get 9 over 4. Did I reduce it right? And if you want to do how do you get that? If you just want to like quick and dirty, you put it in here, and then you like turn it into a fraction. It will reduce it for you. It's 25 over 16. See, I did it wrong. Okay, 25 over 16. Whoops. So that means my side ratio is the square root of the area. So that's where the 5 over 4 comes from. So side ratio 5 over 4, which is that one to that one, is 10 over x. So 5x equals 40, x equals 8 inches. Okay? Draw the pictures, it helps. You do this one's almost the same question. So this one, you've got a billboard, it's 12 feet high and 27 feet long. And then you've got a smaller one, and it is similar, its area is 144 square feet. And they want you to find the height. It's almost the same question, right? Find that area, multiply those two guys. 324, I think. I hope. So I find my area ratio, 324 to 144. And let's see if I can figure out what that is. And that one I think is 9 over 4. Right? Which makes my side ratio, takes 4 roots, 3 halves. I'm trying to find, this one's 12, that's the one I want to find. 3x equals 24, x to the again is 100. Correct? Am I watching? I can't tell. I don't know. Is this helpful, not helpful? If you don't need it, I won't do it. And then you just want to draw a picture here. You got rectangle 1, you got rectangle 2. I don't know what their sizes are. They're similar. So this perimeter here is 48 inches. Rectangle 2 is 30 inches by 18 inches. And they want you to find this area. Well, I know what this area is, or I can find it. It's 18 times 30. 18 times 30, is that 540? Somebody tell me, is that right? Okay, that's that area. I don't know this area. I know this perimeter, though. Can I find this perimeter? Yeah, it's a rectangle, so that's 30, that's 18. Add up all those sides, and you get a perimeter of what? 96? And all I did was I added up the sides. 18 plus 30 plus 18 plus 30. I did it right, it's 96. So perimeter ratio is just like a side ratio. They're the same thing, just directly, 48 over 96. And that's, oh wait, I know what that is, it's 1 over 2, right? Okay, so what's my area ratio? What's the area ratio? 1/4. 1 squared, 2 squared. And that's gonna be this one that I don't know over the one that I do know. And if you go this way, you go that way, you get 135 square inches. Questions? Yes, sir. How did I get this? I took the square root of this. Because this is area, so I took the square root of that, and that's on this one to this one to this one, 12x. Okay? You got this.